Welcome. Today we'll prove the trigonometric identity that sine of pi over 2 plus theta equals cosine of theta. Let's start by writing out what we want to prove. To understand this identity geometrically, let's look at the unit circle. Here we have our unit circle with radius 1, and here are our x and y axes. Let's mark an angle theta from the positive x-axis. Now let's visualize pi over 2 plus theta. First, pi over 2 represents a 90-degree rotation counterclockwise from the positive x-axis. When we add theta to this, we get an angle that's theta degrees beyond 90 degrees. To prove this identity, we'll use the angle addition formula for sine. The sine of a plus b equals sine of a times cosine of b plus cosine of a times sine of b. Let's substitute a equals pi over 2 and b equals theta into this formula. This gives us sine of pi over 2 plus theta equals sine of pi over 2 times cosine of theta plus cosine of pi over 2 times sine of theta. Now let's recall some special angle values. Sine of pi over 2 equals 1 and cosine of pi over 2 equals 0. Let's substitute these values into our equation. This gives us sine of pi over 2 plus theta equals 1 times cosine of theta plus 0 times sine of theta, which simplifies to cosine of theta. And thus we have proven that sine of pi over 2 plus theta equals cosine of theta. This identity shows the fundamental relationship between sine and cosine functions, demonstrating how they are essentially the same function, just shifted by pi over 2 radians or 90 degrees.